Hello guys, welcome back. This is problem set 9 of the lecture series Signals and Systems. In this video, we'll be solving some questions on discrete time Fourier transform. So let's get started. The first question. Determine the Fourier transform for minus pi less than or equal to omega less than pi in the case of the following periodic signal. So the periodic signal is x of n equal to 2 plus cos pi by 6n plus pi by 8. So we know the formula for the periodic signal, right? So if x of n is given by summation k over n ak e power j into 2 pi by n into jk into 2 pi by n, then my discrete time Fourier transform will be x of e power j omega given by summation k equal to minus infinity to infinity 2 pi ak delta of omega minus 2 pi k by n. So first what we have to do, we have to determine n and we have to determine ak's, and then if we have this form, we can get from minus pi to pi what are the values in the x of e power j omega. So let's get started by finding n. So if you observe your x of n, it has two parts. So one is a constant 2 and the second one is a cosine term. So your constant is periodic for any n, right? Periodic for any n. And what is the period of this? If you see, the omega naught is nothing but pi by 6. So n will be 2 pi by omega naught. This is the fundamental frequency. So it will be 2 pi by 6, which is going to be equal to 2 into 6, 12, right? So when we add these both signals, you will get the period to be 12. So next you need to find the ak's, right? If you observe this equation, you have delta of omega minus 2 pi k by n. And you want this 2 pi k by n to lie between pi and minus pi, right? Then what values of k you require? So pi cancels and you will get minus n by 2 less than or equal to k less than n by 2. And your n is nothing but 12 here, correct? So your k will be between minus 6 less than 6. So your k will vary from minus 6 to 5, right? So let us try to determine ak. Finding ak here is very easy. So I'll use a different color. So you just have to write out the cos term in terms of your complex exponentials. So 2 plus e power j pi by 6n into e power j pi by 8 by 2 plus e power minus j pi by 6n into e power minus j pi by 8 by 2. So if you observe, this is nothing but some more k over n ak e power j 2 pi by n, which is nothing but pi by 6 k into pi by 6 into n. Okay. And if you compare these both, you get a0 equal to 2, a1 equal to e power j pi by 8 by 2, and a minus 1 equal to e power minus j pi by 8, pi by 8 by 2. So again, this 0, 1 and minus 1 is in the range what we determined it to be. So we can directly write out x of e power j omega equal to summation, or summation you can take it out. You will get 2 pi a naught into this equation, right? Delta of omega. So 2 pi a naught into delta of omega plus 2 pi a1 into delta of omega minus 2 pi by n plus 2 pi a minus 1 into delta of omega plus 2 pi by n. So substituting all our values, what will we get? We'll get 4 pi delta of omega plus a1 is e power j pi by 8 by 2. So pi e power j pi by 8 delta of omega minus pi by 6 plus pi e power minus j pi by 8 delta of omega plus pi by 6. and your omega is nothing but it is less than pi, less than or equal to minus pi. So this is what we want and we got it. Okay. Moving on to the next question. So we have determine x of n when its Fourier transform is x of e power j omega equal to 1 by 1 minus e power minus j omega into sine 3 by 2 omega by sine omega by 2 plus 5 pi into delta of omega for omega between minus pi to pi. So you should notice two things in the question. The first one is this one. So this one is your x of n being some rectangular thing, right? Like this. So this will give you this kind of x of e power j omega. And also the second part is you have to notice this. Let me use a different color. So this is nothing but the accumulation property. Right? So first we'll try to find the x of n for corresponding to this x of e power j omega. So you needn't remember the properties or the signal. You just assume, let's say x of n equal to 1 for n mod n less than or equal to n1, 0 otherwise. So now if you find your x of e power j omega, it is nothing but summation n equal to minus infinity to infinity x of n e power minus j omega n. So this will be summation n equal to minus n1 to n1. X of n is 1 e power minus j omega n. So now you should use your sum of GP. Your a will be e power j omega n1 into r power n. Your n here is 2n1 plus 1. So you will have e power minus j omega into 2n1 plus 1 minus 1 divided by your r is e power j omega. So e power j omega minus 1. So this, if you try to simplify, what will you get? You will take e power j omega into 2n1 plus 1 by 2, and from bottom you will take minus j omega by 2. So this and that, those terms will cancel, and finally you will arrive at sine of n1 plus half, and also omega you will have sine omega of n1 plus half divided by sine omega by 2. So now you can see. So you need sine 3 by 2 omega by sine omega by 2. So your dt of t. So your n1 is nothing but 1 here. So your x of n is equal to 1 for mod n less than or equal to 1, 0 otherwise. So let's call this as your x1. Okay, and this is x1 of e power j omega. Now we know the accumulation property. So summation n equal to or k equal to minus infinity to n x of n is gonna give you, or x1 of n give you a dt of t of 1 by 1 minus e power minus j omega x1 of e power j omega plus the dc term, right? So which is nothing but pi into x1 of e power j0, and you will have it repeated between every 2 pi interval, but since you are considering only from minus pi less than omega less than or equal to pi, only this is sufficient. So we need to find your x1 of e power j0. So if you substitute omega equal to 0 here, you will get 0 by 0 form. So you have to consider taking limits. Sine 3 by 2 omega by sine omega by 2. So how do you write this limit? Omega tends to 0. Sine of 3 by 2 omega by 3 by 2 omega divided by sine omega by 2 by omega by 2. Here since I divided by 3 by 2 omega, I'll multiply by 3 by 2 omega. And similarly here I'll multiply by omega by 2. So what will I end up getting? This will all tend to 1. So I'll get 3. So your summation k equal to minus infinity to infinity x1 of n which is given by this, will give me the dtft of 1 by 1 minus e power minus j omega x1 of e power j omega, which is what I wanted, right? Sine 3 by 2 omega by sine omega by 2 plus 3 pi delta of 0. Sorry, I forgot the delta of omega here. So delta of omega for minus pi less than omega less than or equal to pi. But what is the question given? 5 pi of omega. So I need to add 2 pi here. So what will adding 2 pi here do it in the time domain? So we also have this property. So for 1, your A0 will be equal to delta of n, right? Delta of k. So here it will be nothing but 2 pi delta of omega. Again, minus pi less than omega less than or equal to pi. So 1 plus summation k equal to minus infinity to infinity. x1 of n is going to give you the dtft, whatever we require. Sine 3 by 2 omega by sine omega by 2 plus 5 pi delta of omega. So first let us look at the integration. So this is from until n only. Okay, this is k. Sorry. My bad. Okay. So let's see the x of n, x1 of n. So it is nothing but 1, 1, 1. So how will your summation x of n from, or x of k, from k equal to minus infinity to n look like? This is n. So this is minus 1, 0, 1. Minus 1, 0, 1, 2 and so on. Minus 2. So until minus 1 it will be 0, right? Because there is no term. At minus 1 it will go to 1. At 0 it will add these both. You will have 2. At 1 it will go to 3. And it is going to remain at 3, correct? So this is your summation. And then you need to get this signal. So this signal is nothing but just adding plus 1 here. So 0, minus 1, minus 2, 1, 2, 3, 4, 5 and so on. So minus 2 it is 1 and even before that it is going to be equal to 1, right? And then at minus 1 you have 2, at 0 you have 3, then 1 you have at 4 and then from then on it is going to be continued to be 4. So that is what is asked. If you want you can write it in this term. So your x of n is nothing but 1 for n less than minus 1, 2 for n equal to minus 1, 3 for n equal to 0, 4 for n greater than 0. So this is your x of n. So here we have used the accumulation property and the Fourier transform of x of n being a rectangular kind of sequence, and we derived the x of n for corresponding to this x of e power j omega. Okay, moving on to the next question. So the following 4 facts are given about a real signal x of n with Fourier transform x of e power j omega. So the signal is real. The first property is fact is x of n equal to 0 for n greater than 0. Okay, and x of 0 is greater than 0 and your imaginary x of e power j omega is equal to sine omega minus sine 2 omega. And the fourth fact is 1 by 2 pi integral minus pi to pi mod of x of e power j omega whole square d omega equal to 3. This is nothing but your Parseval's relation, right? And we need to determine x of n. So the first fact says x of n equal to 0 for n greater than 0. So x of n exists only for n less than or equal to 0. And second fact it says x of 0 is greater than 0. So even your x of 0 is not equal to 0. So this currently it's of no use. We'll see it later, how to use it. And third one, you have your imaginary of x of e power j omega equal to sine omega minus sine 2 omega. So if you remember our property, if you have your odd part of x of n, it was translating to dtft of j imaginary of x of e power j omega. This is for a real and odd signal. Real signal having the odd counterpart will give you j imaginary of x of e power j omega. Why is that so? Your x of n will give you a dtft x of e power j omega, and your x of minus n is gonna give you a dtft x of e power minus j omega, and your x conjugate of n is gonna give you dtft of x conjugate of e power minus j omega, and your x conjugate of minus n is gonna give you dtft x conjugate of e power j omega. So if you see x of n minus x of minus n by 2, this is your odd of x of n. And for real x of n, you can write this as x of n minus x conjugate of minus n by 2. So this is going to give you x of e power j omega minus x conjugate of e power j omega by 2, which is nothing but j imaginary part of x of e power j omega. So your x of n minus x of minus n by 2 should be nothing but, should give you a dtft of j into sine omega minus sine 2 omega. So sine omega, you can write it as e power j omega minus e power minus j omega by 2j minus e power 2j omega minus e power minus 2j omega by 2j. So if you bring the j inside, your 2j will cancel in the denominator. You will remain with e power j omega by 2 minus e power minus j omega by 2 minus e power 2j omega by 2 plus e power minus 2j omega by 2. So this is gonna give you a I dtft of 1 by 2 into delta of n plus 1 minus delta of n minus 1 minus delta of n plus 2 plus delta of n minus 2. But if you compare these both, you know that your x of n is going to be equal to 0 for n greater than 0, and your x of minus n is going to be equal to 0 for n less than 0. So if you compare, you can get your x of n to be nothing but delta of n plus 1 minus delta of n plus 2. Okay, now let me take a new page. So now we got two terms of x of n, but we need to find sum plus a into delta of n, right? Because your odd counterpart will never say anything about your delta of n. So we will also assume that. Then what do we have? The final information is your 1 by 2 pi integral minus pi to pi mod of x of e power j omega whole square d omega equal to 3. So that is nothing but integral minus pi to pi mod of x of e power j omega whole square d omega is nothing but your summation n equal to minus infinity to infinity mod x of n whole square, and it is given as 3. So this is gonna be equal to 1 square plus minus 1 whole square plus a square equal to 3, and you know that your a square equal to 1 and a is equal to plus or minus 1. But this is where the second condition comes, right? Your x of 0 greater than 0. So your a is equal to plus 1. So what will be your x of n? It will be delta of n plus delta of n plus 1 minus delta of n minus 2. So this is your fourth condition, and we have used all our condition to find x of n. Okay. So moving on. The fourth question. Let y of n equal to sine pi by 4n by pi n whole square convolved with sine omega c n by pi n, where convolution star denotes convolution and mod omega c is less than or equal to pi. Determine a stricter constraint on omega c which ensures that your y of n is equal to sine pi by 4n by pi n whole square. So we know our relation that your sine pi or sine w n by pi n is gonna have a discrete time Fourier transform of x of omega given as 1 for your mod omega less than or equal to omega w and less than or equal to 0 and 0 otherwise. Otherwise meaning your mod omega is greater than w and less than or equal to pi. And your x of omega d power j omega is 2 pi periodic. And the condition you also have here is your w should be less than or equal to pi. Otherwise they will start to overlap, right? So strictly it should be less than pi and greater than 0. So now you have your pi by 4n. So sine pi by 4n by pi n is gonna give you a dtft of, I'll draw it straight away. So I have minus pi here, here minus pi, here plus pi, and you have pi by 4 to minus pi by 4 to pi by 4. Okay. And this is gonna be equal to 1. And your multiplication in time domain is translating into your convolution in the frequency domain. Whole square is nothing but your dtf. So this signal convolved with itself. So in this type of convolution, you'll always have a 1 by 2 pi factor. So your x of e power j omega convolved with y of e power j omega is going to give you 1 over 2 pi integral over 2 pi x of e power j theta y of e power j omega minus theta into d theta. Or here I can say x1 convolved with itself. x1 with x1 itself. So what you have to do, let's say this is your x1 of e power j omega. You have to flip this, which will again give the same thing, and you have to move it left and right. So we can easily draw it. So minus pi, pi. Once you flip it and try to left shift, when they will coincide, they'll start to coincide when your omega is equal to minus pi by 4 plus of minus pi by 4. So they'll coincide at minus pi by 2. And then they will linearly increase as one goes over the other, right? They'll linearly increase and they'll reach the maximum when they both overlap perfectly. That will happen at omega equal to 0. So it will become like that. And again, once they start to recede from each other, again the integral will start to decrease. And you will reach pi by 2, where they finally will not overlap each other. So what is the maximum value you will be getting? So 1 into 1. So when you overlap, your height will be 1 and your width is nothing but pi by 2. So you will get pi by 2 here. But also you need to consider the 1 by 2 pi factor. So into 1 over 2 pi, which will give me 1 by 4. That is my max height. Okay. So this will be my dtft of sine pi by 4n by pi n whole square dtft. So by now you should be thorough with this type of convolutions. If you are not thorough or still have questions, please refer back to my previous videos. So now if I convolve this with sine omega c n by pi n. So your sine omega c by n by pi n is gonna have a DTFT of this thing, omega c minus omega c, 1 minus pi and pi. And somehow, if I have the convolution of them, convolved with sine omega c by omega c n by pi n, my DTFT will be product of them, product of their DTFTs. So which means that if somehow my omega c is such that it lets all of the signal pass through completely, then this convolution will just give me only this signal will be left out. And if I take IDTFT back, I'll get only this signal. So that is my requirement, right? My Y of n should be finally equal to sine pi by 4n by pi n whole square, which is nothing but this signal. So this one I want it such that my omega c should be such that when I multiply, let me call it as, what is this? Okay, x2 of e power j omega and x3 of e power j omega, x2 of e power j omega and x3 of e power j omega, I should get x2 of e power j omega, which implies that my omega c should be at least greater than or equal to pi by 2. Okay, so that is my constraint here. My mod omega c is less than or equal to pi is the constraint they have given. And the whatever constraint we got is your mod omega c greater than or equal to pi by 2. So this is what is required. Okay. Let's move on to question 5. Suppose we are given the following facts about an LTI system S with impulse response h of n and frequency response h of e power j omega. So what are the facts? 1 by 4 power n u of n gives g of n, where g of n equal to 0 for n greater than or equal to 2 and n less than 0. So this is nothing but your input to the system. Let's say the system is S and this is your output. So it is not any kind of transformation or DTFT. Okay. And your h of e power j pi by 2 is going to be equal to 1. And your h of e power j omega is equal to h of e power j omega minus pi. So now let us start with the first fact. Okay. So what we are given? We have given input and g of n is our output. And your g of n is non-zero only for n equal to 0 and 1, right? All other places it's going to be equal to 0. So let me write your g of n as some g0 delta of n plus g1 delta of n minus 1. And your input x of n is nothing but 1 by 4 power n u of n. So this is gonna have a DTFT, g of e power j omega as g0 plus g1 e power minus j omega n. J omega. And this one is very easy. You know it is 1 by 1 minus a e power minus j omega. Here your a is 1 by 4. So your x of e power j omega is nothing but 1 by 1 minus 1 by 4 e power minus j omega. So what will be your h of e power j omega? It is nothing but your output transfer function divided by your input transfer function. So it is g0 plus g1 e power minus j omega divided by 1 by this. So you'll have a multiplication. So now you can multiply them inside. So you will have g0 plus g1 e power minus j omega minus 1 by 4 g0 e power minus j omega minus 1 by 4 g1 e power minus 2 j omega, right? So you can group them g0 plus g1 minus 1 by 4 g0 e power minus j omega minus 1 by 4 g1 e power minus 2 j omega. So this is similar to saying your h of 0, right? H of 0 plus h of 1 e power minus j omega plus h of 2 e power minus 2 j omega, right? So your h of 0 is nothing but g0, h of 1 is equal to g1 minus 1 by 4 g0, h of 2 is equal to minus 1 by 4 g1. So it has only 3 points and all other places it's going to be equal to 0. So this much information we got from the first fact. So second fact says your h of e power j pi by 2 equal to 1. So h of e power j pi by 2, if I substitute, you will have, okay, let me write like this only, or I'll put it in h of 0 plus h of 1 e power minus j pi by 2 plus h of 2 e power minus 2j into pi by 2. So this is going to equal to h of 0 minus e power minus j pi by 2 will be minus j. So minus j h of 1 plus h of 2 into e power minus j pi will give me minus 1 again. Right? So minus h of 2 equal to 1. Okay. So this is my second condition. And third condition, my h of e power j omega is equal to h of e power j into omega minus pi. So my h of e power j omega is equal to h of e power j into omega minus pi. So if I try to substitute that in this form, I'll have h of 0 plus h of 1 e power minus j omega plus h of 2 e power minus 2 j omega is equal to h of 0 plus h of 1 e power minus j omega minus pi plus h of 2 e power minus j 2j into omega minus pi. So this is nothing but h of 0 plus h of 1 e power minus j omega into e power j pi. So that is going to give me minus sign e power minus j omega. And here I'll get plus h of 2 e power minus 2j omega e power j 2 pi. So 2 pi is not going to alter anything. It's going to be equal to 1. So I'll just have e power minus 2j omega. So if you see, these terms will cancel. And if I take this to the right hand side, I'll have 2h of 1 e power minus j omega equal to 0, which implies that my h of 1 equal to 0. So this one and this one I can get. My g1 is equal to 1 by 4 g0. Okay. So then what else I have? I have this equation, right? So my h of 0 minus h of 2 is equal to 1 because my h of 1 is already 0. My h of 0 is g0 minus of minus 1 by 4 g1 equal to 1, which implies that g0 plus 1 by 4 g1 equal to 1, which is nothing but g0 plus 1 by 16 g0 equal to 1, and my g0 is 17 by 16, correct? Or the other way, right? My 17 by 16 g0 equal to 1, and which implies that my g0 is 16 by 17. So my g1 is nothing but 1 by 4 g0, which is nothing but 4 by 17. But what is my goal? To determine h of n. So I need to find h of 0. H of 0 is equal to g0, which is nothing but 16 by 17. And my h of 2 is going to be equal to minus 1 by 4 g1, which is nothing but minus 1 by 17. So this is my h of n, and h of n equal to 0 for n not equal to 0, 2. All other cases it's going to be equal to 0. So this is also a very interesting question. Okay, so now let us look at some previous year gate questions. So let h of n be the impulse response of a discrete time LTI filter The impulse response is given by h of 0 equal to 1 by 3, h of 1 equal to 1 by 3, h of 2 equal to 1 by 3, and h of n equal to 0 for n less than 0 and n greater than 2. So only these three are the non-zero values. Let h of omega be the dTft of h of n, where omega is the normalized angular frequency in radians. So your omega, they are given in radians. Given h of omega naught equal to 0 and 0 less than omega naught less than pi, the value of omega naught is equal to. So at some point in the h of omega, the h of omega itself is going to 0. That point is omega naught, and they're asking for its value in radians. So let us try to solve. So h of n itself is nothing but 1 by 3 delta of n plus 1 by 3 delta of n minus 1 plus 1 by 3 delta of n minus 2. And taking the dTft of this will give me h of e power j omega given by 1 by 3 plus 1 by 3 e power minus j omega plus 1 by 3 e power minus 2 j omega. So they're saying at some value of omega naught, this is gonna be equal to 0. So we need to find the solution of this equation. So I'll try to write this in terms of sine and cos, and then we'll see what happens. So anyway, 1 by 3 is common, so I can take it out. So I can write this as 1 plus cos omega naught minus j sine omega naught plus cos 2 omega naught minus j sine 2 omega naught equal to 0. So again, if I group 1 and 1 plus cos 2 omega naught plus omega naught minus j into sine omega naught plus sine 2 omega naught equal to 0. And 1 plus cos 2 omega naught, I can write it as 2 cos square omega naught plus this is cos omega naught minus j into sine 2 omega naught, I can write it as 2 sine omega naught cos omega naught equal to 0. So now I can take cos omega naught common here. So I'll be left with 2 plus cos omega naught, correct, minus j into sine omega naught common here into 1 plus 2 cos, omega naught, and here also I think this is 2 cos omega naught plus 1 equal to 0. Now you can see this term is common, so I can group them into 1 plus 2 cos omega naught equal to 0. So either this equal to 0 or this equal to 0. So this anyway is not going to be equal to 0 because this is a real number and this is a real number, and they are in no case going to be equal to 0. The ratio of two real numbers is equal to some imaginary number. So that is not possible. So I only have my 1 plus 2 cos omega naught equal to 0, which implies that my cos omega naught is minus 1 by 2. And I need my omega naught between 0 and pi. So 0 less than omega naught less than pi. And I know in the first quadrant, my cos is positive. And only in the second quadrant, my cos is negative. So it should lie in the second quadrant. So I can also write it as cos of pi minus omega naught equal to minus 1 by 2. And I can observe my, this, again when I do a pi minus omega naught, I should multiply it with minus 1, right? I'm assuming that my omega naught is in first quadrant. And then if I do a pi minus omega naught, always a pi minus omega naught is going to flip my sign. Even if it is in second quadrant, doing a pi minus omega naught will bring it to fourth quadrant, which will again, it will bring it again to first quadrant, which will again give a positive sign. So my cos pi minus omega naught is equal to 1 by 2, right? So for what value of pi minus omega naught is that possible? It is when your cos is gonna equal to pi by 3, right? Because your pi by 6 is root 3 by 2. So omega naught is nothing but pi minus pi by 3, which is equal to 2 pi by 3. And they are asking for the omega naught in radians. So if you use a calculator, what will you get? So you're getting some 2.094. So if you can round up to 2 decimal places, you can write it as 2.09. Okay. And your answer key gives the range between 2.05 to 2.15. So we are in a good range. Okay. So this is question 1. Now let us move on to question 2. A 5-point sequence x of n is given as x of minus 3 equal to 1, x of minus 2 equal to 1, x of minus 1 equal to 0, and x of 0 equal to 5, and x of 1 equal to 1. Let x of e power j omega denote the dtft of x of n. The value of integral minus pi to pi x of e power j omega d omega is. This is again a very easy question. They have given some 5 points just to confuse you. So if you observe your synthesis equation, you have x of n equal to 1 over 2 pi integral over 2 pi, right? I can write it as from minus pi to pi. And I have x of e power j omega n d omega. So now if I substitute n equal to 0 here, I'll have x of 0 equal to 1 over 2 pi integral minus pi to pi x of e power j omega, and this term is going to become 1, so into d omega, and this is what we want here, correct? So my integral minus pi to pi x of e power j omega d omega is nothing but 2 pi into x of 0. So my x of 0 is 5, so this is going to equal to 10 pi. So this is your answer, option B. Very easy. But also you should learn how to fiddle with these things, right? You should not be sitting and deriving the entire x of e power j omega and then try to find the integral. You will not be able to find it out that way. So this is quick and simple to solve. Moving on. Question 3. Consider the signals x of n equal to 2 power n minus 1, u of minus n plus 2, and y of n equal to 2 power minus n plus 2, u of n plus 1, where u of n is a unit step sequence. Let x of e power j omega and y of e power j omega be the discrete time Fourier transform of x of n and y of n respectively. The value of the integral 1 over 2 pi, integral 0 to 2 pi, x of e power j omega, y of e power j omega, d omega is. So, consider the signals x of n equal to 2 power n minus 1 u of minus n plus 2 and y of n equal to 2 power minus n plus 2 u of n plus 1, where u of n is the unit step sequence. Let x of e power j omega and y of e power j omega be the discrete time Fourier transform of x of n and y of n respectively. The value of the integral 1 over 2 pi, integral 0 to 2 pi x of e power j omega and y of e power minus j omega d omega, rounded off to 2 decimal places is dash. So this is also somewhat related to the previous question. Here also you have the integral over a 2 pi range, but the signal here given here is x of e power j omega into y of e power minus j omega. So if you notice, your y of minus n will have a dtft of y of e power minus j omega. So which means that x of n convolved with y of minus n will have the dtft x of e power j omega, y of e power minus j omega. So let us find this first. So your y of minus n is nothing but 2 power n plus 2 u of minus n plus 1, correct? So let me call it your z of n. So now you want x of n convolved with z of n. So this is nothing but summation k equal to minus infinity to infinity x of k z of n minus k, right? But this integral 1 over 2 pi, integral 0 to 2 pi x of e power j omega, y of e power minus j omega d omega is nothing but whatever this, let's call it w of n. It's gonna be w of 0. It is similar to the previous case, right? Your w of n will be e power minus j omega term here, j omega n term here. If you substitute n equal to 0, that term will go away and you will just get this integral. So what is your W of 0? Summation k equal to minus infinity to infinity x of k z of minus k. And your z of minus k is nothing but your y of n itself. So anyway, we'll write k equal to minus infinity to infinity. X of k is given by this 2 power k minus 1 u of minus k plus 2. And your z of minus k is nothing but 2 power minus k plus 2 u of k plus 1. So this is valid only for k plus 2 greater than or equal to 0, which implies that your k is less than or equal to 2. And what about this k plus 1 greater than or equal to 0, or your k is less than or equal to, k is greater than or equal to minus 1. So this integral only goes from k equal to minus 1 to 2, 2 power k minus 1, 2 power minus k plus 2. So this is nothing but your summation k equal to minus 1 to 2. So k and minus k cancels, and 2 power minus 1 and 2 power 2 will give me just 2. So it is nothing but 2 into sum of this. How many terms are there? You have minus 1, 0, 1 and 2. So 2 into 4, which is nothing but 8. So my integral value is 8. So I can write it as 8 or 8.00, whatever it is. Okay. So this is question 3. And you can see how across the years they have given the same type of concept, but they have given in different forms, something more complex, right? Okay. Coming to question 4. Let x of n equal to 1 by 2 power n u of n and y of n equal to x square of n, and y of e power j omega be the Fourier transform of y of n. Then y of e power j omega is, again this is y of e power j0. So this is again an easy question. Since they have given x square of n, it's not necessary that you should do the convolution in the frequency domain, right? Your x of n is simple. So your x square of n is nothing but 1 by 2 power 2n u of n into u of n. U of n into u of n is going to give you u of n itself. And this is nothing but 1 by 4 power n. So for this you know your DTFT. So a power n u of n is having a DTFT 1 by 1 minus a e power minus j omega. So your y of e power j omega will be nothing but 1 by 1 minus 1 by 4 e power minus j omega. Y of e power j0 is 1 by 1 minus 1 by 4, which is nothing but 4 by 3. So correct answer is option D. So this is again very simple. Okay. So that's it for today. So I hope that you were also able to follow whatever I said. Maybe you can also try solving these questions and then see how well you have grasped the concepts. So I'll meet you in the next video. Until then, take care. Bye-bye.